Right, here's some questions that deal with quadratic equations or quadratic functions. The first one says solve that equation and then find the x-intercepts. And notice that this is the same as this. Well, solving this equation is the same thing as finding the x-intercepts for that equation. And the reason why is because f of x is the same thing as y, or you can think of it that way. And in a graph, an x-intercept happens when y is equal to 0. So if I change that y to make it 0, then this is exactly the same as question A. So to solve this, you need to deal with the brackets here. So I'd have 3x plus x squared minus 2x equals 0. If it's a quadratic, keep things on the one side typically. So I'm going to have x squared plus x is equal to 0. Now I'm going to factor this. There's not a number here, so I can't do a trinomial factor thing. But there is a common factor I can take out of both of those, of an x. So then I'm left with x plus 1. And then I've got a 0 property. So I have this thing times this thing is equal to 0. One of them has to be 0. So either x is equal to 0, that's one of my answers, or x plus 1 is equal to 0. Solving for x, in this equation I subtract 1 from each side, I get x is equal to negative 1. So negative 1 and 0 are my two answers to that question. I could go out and check one. Let's check the negative 1. So my equation is 3x plus x times x minus 2 equals 0. Let's plug in a negative 1 and see what works. Negative 1 times negative 1 minus 2 equals 0. That'd be minus 3 plus, this would be negative 1 times a negative 3. And negative 1 times a negative 3 is a positive 3. So I have minus 3 plus 3, and sure enough that equals 0. So that one checks. And you could check that one too. Alright, another dealing with quadratics is this one here. To solve that one, I'm going to get rid of brackets, so it'll be 14x minus 56. Then this is a dirty, rotten, filthy, stinking negative, so it has to apply to both things in the brackets. So it'd be minus x minus 2 is equal to, and now I'll FOIL that, x squared minus 4x plus 2x minus 8. Okay, collecting like terms on each side, here I'd have a 13x minus 58. On the other side I've got x squared minus 2x minus 8. Since it's a quadratic, I'm going to move everything to the right side. So I'm going to have 0 is equal to x squared minus 2x minus 13x minus 8 plus 58. Okay, and then x squared minus 15x, negative 8 plus 58 would be 50, so plus 50. So, again, it's a quadratic. This time it has an x squared, x, and a number, so I can try and factor it into brackets like this. I'm looking for two things that multiply to 50 and add to a negative 15. So I'm thinking it's a minus 5 and a minus 10. So to solve it, it'll be x minus 5 equals 0, or x minus 10 equals 0. And on the first one I get x equals 10 or 5, and x is equal to 10. So those are my two answers for that question. And I can, again, check those to make sure that they work. You can do that. Alright, the last question in this section with quadratics is this one. And the question says you've got a field, and where you have a width, and they said the think it's the length is equal to w minus 51 or vice versa. So I think it's they say the width is 51 less than the length. So this width over here will be the length minus 51. But then they say the diagonal, that's this distance, is 250. So this distance over here is L. So if I just look at this triangle, I guess I was thinking to use an area because I have a width and a length, but they gave me a diagonal. They didn't give me an area. So if they give me a diagonal, then I've got to use Pythagoras to solve that. So Pythagoras is c squared is equal to a squared plus b squared. C is this longest side, so 250 squared is equal to a, we'll use the a for L, so L squared, plus b is L minus 51 squared. And then this question is similar to the ones we've done before. So this would be 62500, I think, is equal to L squared, and then I'd have to FOIL that. So it'd be L squared minus 51L minus another 51L plus whatever 51 times 51 is. Okay, and then it's a quadratic. Gather all the stuff over to the right side and then see if you can factor. If you can't factor, then yes, you would use the quadratic formula like you were trying there. Here you tried the area thing, but the question, this 250, was a diagonal, so you have to use Pythagoras. All right, hopefully that helps you with those questions.